So I have the task of being the last speaker, right? At the graveyard session, which is actually quite daunting. And then, of course, trying to cover somewhat new ground, given that most people have already spoken about a great deal of things. But I think what I am going to cover does, interestingly enough, without planning, I suppose, dovetail a fair amount with what some of the previous speakers have mentioned. So we, without it really being a conversation about all of the stuff that the CSIR is doing and it becomes a big marketing pitch, what I decided to do was talk a little bit through the thought process of what's happening and how we're analyzing and looking about, so let's see, where's the, it doesn't work. Laser pointer not working? This one here, press this one. This one. Okay, great. Is to look at what smart technology implies for the industry of the future, and then of course take that back into the kind of technology developments that we're looking at and perhaps even already starting to implement from an R&D perspective. So I think what we've all heard and know about is that connected products will be the way of the future, right? Or even connected smart products. And I guess the key point is, what does that mean for the manufacturers of these products, or more importantly, for the manufacturers of products that have not yet embraced a digital future? And so from that perspective, I'll start with the conclusion to hopefully maybe save time and keep everyone interested, and then kind of trace this journey of how we get to that. And the conclusion essentially is that a digital connected future will imply products that have customized customers' experience, and that will be the business model that you have to adopt. Right? So now the question is, how do we get there and what does that all mean? And I think everyone's kind of seen the journey slide. We don't have to go through this in a great amount of detail. Industrial age, discrete products produced, distributed in some way. And just kind of jumping forward into the information age, where we had some level of automation and then electronic data collection. But I think the interesting or the important part of where we are in this information age is these kind of media breaks, where the continuous flow of data that was collected had these breaks in them, and what you had to do was introduce human beings to kind of continue that flow. And what they did was slowed the process down and made it quite costly. And then, so if we look forward into the future, which is this service-orientated, connected product space, it's these breakdown of the media breaks, or the elimination of those. So you have these continuous streams of information that create these connected services products. And this model, where you take embedded intelligence, data analytics, Internet of Things, cloud, but quite importantly, imagination, right? And you kind of put all of those things together is the orientation from what we're looking at or what thinking about from the smart systems point of view. So in this environment in which you have data that is streaming, because you've broken down or eliminated these discontinuities or these media breaks, we kind of envisage a ubiquitous Sense8 environment, right? So what does that mean is that you've got all of this data streaming to you because you have these cognitive engines, essentially software-enabled machines that are spread out in that entire environment, and it's streaming all of this data and information to you. Now, this environment was actually envisaged probably for the first time, although I guess from a science fiction point of view, we've been reading about it for a number of years, by MIT's Media Lab round about 91. And so it seems as though we're rapidly moving in this direction, predominantly driven by the acceleration in wireless sensing and the network that enable these things to connect. And it's not just Wi-Fi, because now there's a whole range of new sensing technologies and approaches that enable the data, even though they may at low data rates, but being able to stream over very wide areas, and then you connect these systems. So the software-enabled machines are then able to respond, and this is the important part, relevantly to real-world events, right? And to some extent even predict what is going on, which is where I guess it maybe becomes a little bit scary. Now, the connectedness of factories and production lines or various industries is actually one of the important factors for us, and we're trying to think through that and what does that all mean. But the idea of a connected factory was not actually new. It's been around for a long time, all the way from paper milling even through to heavy industry. And I think the important thing is the scale at which it's happening. And when you have these ubiquitous sensors that are not only embedded in the product, but in the production line and in the machines and in that entire environment, and what we would call the industrial Internet of Things, and how that then merges with the consumer space with a much more consumer Internet of Things environment. And then you have these factories that are joined with their machines and their products into this connected web of information flows. And that's where it all starts really becoming interesting, because that forms the foundation for Industry 4.0. And a number of companies are now interested in this, and some of the research that a number of forecasting and future foresighting companies have looked at, kind of look at these things: improving quality of service of the product, productivity, reliability of operations, a whole lot. I think we've all heard about this, right? And so they're kind of driving towards that. But there are these 4 key productivity improvements at the product level that I think are most interesting. And I want to talk a bit about them, because that's what's guiding how we think about products of the future. And I think the thing is that from a implementation point of view, these things are happening, and we'll talk a little bit about some of the examples of that, because this future that we're thinking about or looking at is not actually all that far away. So I think the first thing is the production line is online. So the machine conditions are continuously measured and analyzed, and there are various states used to train algorithms which predict future failure conditions and schedule preventative maintenance. Now, what's happening, and this is quite the interesting part, is that all of the data that's streaming around that's being collected probably are first seen by a machine before any human eyes touch it. Right? And they are then producing insights that you have to action and act upon. I think the next part is then that the product is connected. And in fact, the product becomes alive as soon as it possibly can. And that means in the production line, its embedded sensors start relaying their state immediately once created, which enable the factory to analyze and optimize the production, and the quality deviations are detected, and the production line can then be dynamically changed and optimized to start reducing any kind of quality defects that might happen. And then the really interesting stuff starts happening, because the product life cycle becomes extended. So in this case, the machines and the products in the field will relay their status back to the manufacturers, such that engineers can work on software updates and then propagate this over the air into the product. Now, when I saw your Tesla example, I said, oh shit, sorry. I thought, oh, good. That's my example gone. But interestingly enough, you didn't. Because in this product life cycle extension, Tesla demonstrated that exactly thing right now, right? And that was during the Hurricane Irma, if I'm not mistaken. What they did was they did a software update over the air to all of the cars in the Florida area, and enabled it to get extended range so that they could get away from that environment, right? And what they did was exploit it, or made use of, I guess, a hidden feature in the connectedness of the car, which enabled it to change the engine management system, reduce less power, but also access this kind of reserve in the battery that was sitting in there. Now, if you, project forward, potentially, if you only have enough money to buy a 1400 car, okay, then you do so and you save up, and then when you're ready to upgrade, you just send them your credit card and then they upgrade your car, and the next thing you have an 1800. But already the car is connected to your phone, to your watch, all of those kind of things, and they're creating this entire ecosystem of entertainment and information that's flowing into them. And I think that's probably over and above the fact that they are future orientated to give you the self-driving capability, is that they created this kind of economic ecosystem all around it. Then products become service intensive. And from the earlier discussions, there were a few questions around this, where the products, and in this case, something as vast as advanced as a jet engine, is instrumented down to individual turbine blades, so that the information can be analyzed retrospectively, but also in real time. And GE is doing this already, and I think Lufthansa is probably one of the examples of where they're doing this, where maintenance is scheduled proactively, turnaround times on the aircraft is completely increased, And more importantly, in this kind of servitization, the aircraft company never actually owns the jet engine, right? It's actually leased to them, and then it's continuously improved, and maintenance is done. So if we now turn to some of then the actual practical implementations, the work that we're doing from an R&D perspective, that while looking at this kind of future vision, it's work that we've probably started about 2-3 years ago to try and keep our eye on where we're at. Now, we've heard, for example, around AeroSwift, which is the 3D printing machine that essentially sits right between the titanium beneficiation and breathes life into the South African aerospace industry. But we're also thinking about, well, how do you add intelligence into that machine? So, for example, as each layer is printed, you're doing image processing on it, and you can actually start spotting defects in the product or in the part as the thing is being produced. From a power point of view, we're looking at what we call smart spatial solutions. And in this case, around nuclear plants, for which we have two. Well, we have a nuclear plant and then we have a nuclear facility. And how do you look at increased regulatory compliance, but then also adding an additional service around that? And in this case, radiation sensors that are IoT enabled, spread out over actually several hundreds of kilometers between Pelindaba and Coburg, and then stream all of their data into this sort of common backend. But this is actually what it gives you. It gives you the ability of first visualizing and seeing what's things happening at a spatial level, whether you want to look at it at a country level all the way down at the city level. And through spatial interoperability, we know who might be affected by radiation increases anywhere around that, and then also with weather information where that could propagate. Then you also get, let's call it the machine information. So what's happening at the sensor level, sensor health checks, sensor health information, either at an aggregated level or at an individual sensor level. And then down here is all of the various analytics. Alert me when the radiation levels go above a certain parts per million or whatever needs to happen. I think the next one, which is quite interesting, is digital disruption in publishing. Now, in South Africa, and this and the whole thing we're looking at here is the human technologies aspect, because we spoke about augmented reality and how is all of that going to feed in. But the man-machine interface is actually quite a key thing to look at. And in this case, working from the language parts of it, we're looking at kind of integration amongst this ecosystem. Sorry if I'm blocking, right? Where guys that are currently in a kind of uneasy relationship between the authors and the publishers, and then the digital books or the ebook aggregators, they're currently kind of disintermediated at the moment. But how do you pull all of those things together and create a completely new ecosystem? And in this case, where we start bringing in human language technologies, where you in a faster way produce audiobooks, but enhanced audiobooks. So not only do you have audio, but you have text. And what that does is it starts and they are aligned and searchable, almost immediately. But what that does is that it gives you completely new markets and new opportunities. And in South Africa, importantly, can help from a literacy point of view, because this technology not only brings in audio producers, but it also has synthetic voices in all of the different languages. So you put this thing together and you immediately create new products around audiobooks. And ultimately what we're trying to do is this. We're trying to get away from this to that, increase literacy, help at early learning stages, and for the publishers, creating a bigger market. But there are still some technical challenges that remain for this widespread adoption, and those are kind of at the technical level, the things that we're interested in looking at and trying to develop around. And the first thing is interoperability. It is not actually easy to get the software and the machines and the communication devices to just seamlessly work, right? Ultimately, when you put your washing machine down, you wanted to just talk to your Wi-Fi system immediately and it becomes online and you can get your phone to talk to it, right? We can't actually, it's not yet ready because the interoperability parts and all of the standards are not quite in place. I think the next thing is on information transparency, and someone had something on what we call the digital twin. But how do you discover what sensors are out there? What data does it have? How do you access that data? And then importantly, how did you build an application that makes use of that data and other systems that might be in its immediate environment, so that we can create the decision support tools, which is what all of the technology is actually about. And how do you make life better for the human beings? How do you get to be able to do things in difficult environments, or perhaps even help people that are not able to operate properly? And then the part on the last part, which is on decentralized decision making. This is when you try to move the intelligence sort of to the edge in the embedded system, so that it can both analyze, make decisions, and actuate autonomously. Right? And so there's a lot of work that still needs to go on in all of that. And so to conclude, again, connectedness without a doubt is driving new business models. And I think that this is probably the most important part. The challenge of being able to continuously imagine the future world and keep pace with the change, so that industries remain relevant and competitive, is the work that still needs to go on. We'll solve all the technical problems, without a doubt. But imagining, like you said, keeping your eye at where the puck is going to be is the key thing. And it's difficult. And it's for that is where you need the highly creative, imaginative people. And there was a talk that I heard a few days ago that said, for South Africa, it is probably more important for us to be able to adopt and localize technology, adapt it and use it, than to try to create things absolutely brand new and from scratch. Thanks.